Unit 4, Learning Target 3A, I can identify the end behavior of polynomials. We are going to use this to sketch polynomials along with the roots, the intercepts, the minimum and maximum values. Right now, though, we're focusing on the ends of the graph, and we're only focusing on the ends of the graph. The part of the graph where the arrows are pointing. So if the graph were to actually end and not have arrows forever and ever and ever and ever and ever, where would the arrows end up? So for this first function, we have that p of x is equal to x to the fourth minus 3x squared plus 2x minus 6. Now, we know from Unit 1, when we were looking at parent functions, that an x to the fourth has a general shape like a quadratic, being that it looks kind of like a U. And since we're only looking at the ends of the graph, we don't need to really worry about what's going on in the middle, just what's going on at the ends. So for now, we're going to look at just what's going on at the ends. So I'm not worried about whether I have any turns in the middle. I only need to concentrate on these arrows at the ends of my graph. So where are they going? One of the things we do need to remember is that if the degree is even, and in this case we have a degree of 4, 4 is an even number, then both of the arrows will point in the same direction. So what we're asking ourselves is actually fairly straightforward. As I move along the x-axis, in a positive direction, where is my function headed? Where is the y headed? And in this particular problem, the y is headed in a positive direction, and it continues on forever, so it continues on to positive infinity. So we actually say that the function f of x approaches, that's what the arrow means, positive infinity as x approaches positive infinity. Because we had the x going on and on and on and on and on this direction, headed off to the right, that's in the positive infinity direction. Now we do the same thing with the other side. We think about following this graph off to the left. So we're following to the negative x's. So the x's are going towards negative infinity because they're going in a negative direction forever. Where is the function headed? Well, this function, as this particular graph heads to the left, continues to head up into a positive direction, and it never stops. So this function, f of x, approaches positive infinity as x approaches negative infinity. Noticing that because it is an even degree, both arrows are pointing in the same direction, I say that the function is going both positive infinity both times, because both arrows are going in the same direction. Now for our second example, we have p of x is equal to 2x cubed minus x plus 3. Again, we're not worried about the minimums and the maximums at this particular time. All we really need to concentrate on right now are the arrows. And if we go back into our Unit 1 filing cabinet in our mind, and we open that up, we remember that a cube does have a general shape of starting low and continuing to go high with arrows on both ends. So we do want to remind ourselves that an odd degree, 3 is the degree and 3 is an odd number, the arrows point in opposite directions. But we're going to ask ourselves the same question. So as we follow the x-axis to the right in a positive direction, what is the function doing? Well, this function, as we follow it to the right, is continuing also in a positive direction. So it continues forever, meaning that the function f of x is approaching a positive infinity as x approaches a positive infinity. Now, same thing for headed off in a negative direction on the x-axis. As we're heading off to the left, the x is heading off further and further and further to the negative direction. What is the function doing? Well, the function, as I head off to the left, is going down and down and down. The function just keeps going down. So the function is decreasing or headed to negative infinity. So the function f of x approaches negative infinity as x approaches negative infinity.